Okay, so today we are working on one-step equations still. That's what we did yesterday, or 2 days ago. But today we're working on inverse operations, multiplication, and division. So inverse operations dash multiplication. Put a slash division if you can get it in there. Okay. And the date is 10/30/19. So still people are having issues and trouble recognizing what they're supposed to do with these problems. And I think people are either overthinking it or just really not thinking about it at all. All we're doing, inverse, get this through your head. Inverse means the opposite of what is being done. Okay, so we're just looking for what is being done in the equation and then doing the opposite of it to get rid of it. So, like I said, you have $3 in your pocket. How do you get rid of $3? You subtract $3 by spending it. So now you have 0. That's what we were trying to do with adding and subtracting. Now with multiplying and dividing, we're trying to make ones. Okay? And maybe you'll start to understand that. It's not really a terribly difficult thing to do, but you just got to remember, addition is the inverse operation of subtraction. Subtraction is the inverse operation of addition. Multiplication is the inverse operation of division. And division is the inverse operation of multiplication. They're opposites. That's all it means. So we look at an equation. So I'm going to start with number 1. It's a very, very simple example of a one-step equation. What do we see there? How do we read that? You might be reading it as 3x equals 36, and later on that's fine, as long as you recognize it's 3 times x is what that means. It really is 3 x's is what that is saying. So it is 3 times x. I'm just going to put a little dot to remind us that's 3 times x equals 36. Now, what is the inverse operation of multiplication? That's what's going on here, right? We're multiplying 3 and x. The inverse operation, or opposite, is division. So we have to divide to get rid of that 3. So we just divide. And this is how division looks. This is going to confuse some of you. Because yesterday people were putting that bar there thinking that's where it went, when it was an equal bar yesterday, and it goes below when you're doing addition and subtraction. It doesn't go in the middle. This is how division looks. It looks like a fraction. Okay, so if there's multiplication in your equation and you're trying to get rid of it, you divide, and it looks like this. Now, remember the teeter-totter. Okay, I just did something. I put a number in here and did an operation to the left side of my equation, the left side of the equal sign. I have to do the exact same thing to the right side of the equal sign. Divide by 3. You don't divide by 36. You do exactly what you did on the left. You divide by 3. Hopefully you're seeing this right here. And I did another line. See, I came down one line. Everything's lined up. Okay, so I have my original equation in the first line. I have my inverse operation in my second line. Now I'm going to go ahead and have what's left on my third line. Now, 3 divided by 3. I'm right here. I'm looking at this 3 divided by 3. Well, what is 3 divided by 3? It's 1. 3 goes into 3 one time. So maybe just to remind yourself, I'm going to make a big 1. That's 1x, okay? I'm going to write 1x. I don't have to write the 1, but you can. Equals. Now I got to divide on the left side. What's 36 divided by 3? Well, this you might have to go over here. And what I want you to do, if you're going to do work like this, is do it way off to the side. If you can't do it in your head, top dog goes in the house. 36 goes inside because it's the top number. Not the biggest number, the top number of the fraction goes inside the division bar or division sign. 3 goes into 3 one time. 1 times 3 is 3. Subtract that's a 0. Bring down the 6. 3 goes into 6 2 times. 2 times 3 is 6. Subtract the 6, that's 0. I'm done. So 36 divided by 3 is 12. Now I can rewrite this, and I'm going to rewrite it a little different. Just x is equal to 12. I just got rid of the 1. You don't have to write the 1 in front of a single variable. We can see there's an x there. There's one of them. So we don't have to write the 1x. Kind of like saying if you're 12 years old and somebody said, how old are you? And you would say 1 times 12. Would you do that? No, you just say, I'm 12. You don't need to say I'm 1 times 12. I'm just 12. It's kind of the same thing. You don't need to say 1x, just x. So now we know what x is. Now here's another part where people are not paying attention. I'm going to use the exact same equation I had before to check it. This is not an optional step. You have to do this. I want to see it, or you are not going to get full credit. Now, I've got my original equation written exactly as it was over here on the left. Now, I'm going to take out my variable and put in some parentheses. Then I'm going to plug in the number I found, my answer. Okay? Oops. I'm going to plug in 12. I'm not done. What I'm doing is comparing the two sides of the equation. What's on the left needs to equal what's on the right. So I got to carry through on my calculations here. 3 times 12 is 36. Okay, cool. I got 36 on both sides. If I got 36 on both sides, that means my answer works. The calculations worked out. Okay? Let's go over here and do another one. Negative 108 is equal to 9 times m. If you want to do something like that to remind yourself, fine, do it. Okay? So it's 9 times m. What is the inverse operation or opposite operation of multiplication? It's division. So we divide by whatever's in front of the variable. And when I say in front of the variable, I mean if you're reading a sentence left to right, the first word is in the front of the sentence, right? So the 9 is in front of the m, and it's a positive 9. And that was the same case over here on number 1. It was a positive 3. The whole thing was positive. I didn't have to worry about negatives. This one I'm going to have to worry a little bit about negatives. Now, if I divide by 9 on the right-hand side, I need to divide by 9 on the left-hand side. Exact same operation. I'm seeing people put different numbers down there. You don't. It's the exact same thing. It'd be like it's almost like when you have that teeter-totter situation and I take 2 away from one side and somebody adds 8 on the other side. That doesn't make it even. If you take away 2 on one side, you got to take away 2 on the other side. You add 8 on one side, you got to add 8 on the other side to keep it even. Division and multiplication is the same thing. You have to divide by the exact same number on both sides. So, let's look at what we're end up with. 9 divided by 9, that's a big, huge 1. I'm left with just the m. Okay, the m doesn't go to 1m. I don't need to write the 1. The m stays there. The equal sign comes down. Now I got to do negative 108 divided by 9. On the left-hand side, how many negative signs do you see? There's 1 negative. That means my answer is going to be negative. Now I just got to figure out what's 108 divided by 9. I'm going to do some work over here. Top dog goes in the house. That does not mean the big number. It means the number on the top of the fraction. So 9 goes into 10 one time. 1 times 9 is 9. That gives me a 1. Bring down the 8. 9 goes into 18 twice. 2 times 9 is 18. Subtract that. Cool. 0. 9 goes in 12 times. But my iPad gets unstuck here. We know that it's going to be negative 12. Now, let's check it. So we come over here to check it. We write the exact same equation we started with. Then we rewrite everything the same way, and this time take out the variable, put in parentheses, and place the number that I had inside the parentheses, the number I came up with as my answer for the variable. Then the negative 108. Notice, the negative 108 never changes. You don't change something just because you feel like you need to change it. Okay, the negative 108 does not change. It stays the same unless you actually do some operation to it to change it. And we're not trying to do that right now. Equal sign stays. 9 times 12, I know that's 108, and it's a positive times a negative. Negative 108 is equal to negative 108, so guess what? We know our answer works. Okay? If these equal each other, then we know our answer was correct. Let's do a division one. This is a division problem. Okay? X divided by 17 equals 3. Now what you might want to do is rewrite it so you have a little bit more room to do these. And I would suggest you go ahead and rewrite these so you have more room, because we're going to need a little bit more room to do this stuff. Now, I'm looking at this problem, and the way that is read is X divided by 17. That is what that is. That is how division is going to look pretty much from now on for the rest of your math lives a lot. You will see it looking like a fraction. That is X divided by 17 equals 3. What is the inverse operation of division? It's multiplication. Well, how do we do that? It's very, very simple. And remember, we're just trying to make a 1 on the side where the variable is. So all I have to do is go over here, put a 17 times the whatever's in the numerator on the top of your fraction, put a 17 over here. We're multiplying by 17 on both sides. Now the cool thing is, you don't have to do anything on that left side, because guess what? 17 divided by 17 is 1. So I'm left with 1x. That's why we do it, to get rid of that number. But I have to do something with it. I got to do the same thing on both sides, which I did. I multiplied the right-hand side of my equation by 17 also. 3 times 17, well, if you need to do this over here just to do the math, this isn't checking, this is doing math to get your answer. 3 times 7 is 1, carry the 2, because 21. 3 times 1 is 3, 4 plus 2 is 5, so that's 51. So X equals 51. So let's check it. So we go over here, write the exact same equation. Okay? Then we're going to take out our variable, put in parentheses. Everything else stays the same. Okay? Everything else stays the same. Notice, nothing has changed except my variable. I'm going to plug in the number I got for X, because I found out, okay, X is 51. So I took out X and put in 51. Now I just got to figure out, okay, what's 51 divided by 17? Now, this might be a little harder to do, but guess what? Since we already know this, we got to know this. 51 divided by 17 is 3. So 3 is equal to 3. So we know this works. Okay? Solve. Check. Okay, this is how I want to see all your problems. Look how clean this is. How I can see everything. I've got everything separated. You might want to put even work over here. Okay? Very simple and clean. You can see exactly what is going on in this problem. How I solved it by going down line by line. Let's look at one like, they're all kind of the same. Let's do number 6. I'm going to rewrite it so I can have a little bit more room. And I'm telling you, rewrite these division problems. Do it so you have more room. It's not optional. Rewrite it so you have the room to work. V divided by negative 2 equals 16. Very simple, straightforward problem. It's division, correct? I see a division problem. What's the opposite of division? Multiplication. All you got to do, multiply by whatever is in the denominator, the bottom number below your variable. Do it on both sides. Exact same number. We're just multiplying both of them. Okay? Fractions are really easy to deal with in algebra because you're just getting rid of the numbers. Again, that's a big 1. Negative 2 divided by negative 2 is 1. It has to be the exact same number, exact same sign. If you're not following that, you're not going to get this answer right. So I'm just left with 1v. I don't have to write the 1. 16, a positive times a negative is going to give me a negative. 16 times 2 is 32. There's my work, or my solving it. Now I need to check it. So I rewrite my equation. Exact same way it was. Nothing changes except the things I'm actually doing to the equation. I found out down here v is negative 32, so I'm going to take out v, put in negative 32. Everything else stays the same. Nothing changes except the one thing I substituted, the negative 32 for v. Now, a negative divided by a negative on the left side, that's negative 32 divided by negative 2, it's going to be a positive answer. And if you need to, you can do the work over here, 32. We already know it's going to be positive, so we don't have to worry about the signs. 2 goes into 3 one time. 2 times 1 is 2. Subtract that, we get a 1. Bring down the 2. So 2 goes into 12, 16, 6 times. 2 times 6 is 12. Subtract that, we get 0. So our answer is 16. So we get 16 on the left. Oh, well, great. And it equals a 16 on the right. Notice this whole side, this number, never changed. The sign didn't change, the number didn't change. A lot of you are changing things just because, oh, the answer didn't work, so I'm going to change this number on the right so it matches. That's not what you're trying to do. That immediately will make the whole problem wrong, because you're going to think, oh, I got it right. I just made the numbers match. That's not what algebra is, matching numbers. That's kindergarten. Matching numbers is kindergarten. We're not matching numbers. We're trying to see if the two sides are equal. Okay, and I never change that number on the right. There's too many times I've seen people make a mistake on the left, and then they just change that number on the right randomly to whatever's on the left so that they think, oh, I got it right. No, that's not how that works. They have to stay the same, and they have to be equal. Okay, so I know v equals negative 32 is correct because 16 equals 16. I want you to do the rest of the odds, all the odds on this paper. So you need to do 3, 7, 9, 11, 13, 15, 17, 19, 21. Okay, these are all problems you're going to need to do. Down here it's mixed review. It's not going to be all multiplication division. As you can see, 17 and 19 are not multiplication or division. 21 is. But the couple things you need to understand, 13 and 15, product. I've talked about that in the past. That's multiplication. Quotient. I've also talked about that. That's division. So I've kind of given you a little bit of a head start on those. When you are done with this, you are to grab the homework, and you will be responsible for the odd problems on the homework. And if you finish the homework, I may have you work on another paper that's a inverse operations maze paper. So that is the plan for today. If you have any questions, please